In previous videos, we created a custom subnet mask for a Class C address. With a little practice, most students master this process quite easily. The challenge that many students have come when they try to subnet a different class of address. In this video, we'll subnet a Class B address. We'll use the rules of subnetting that we discussed in the previous videos and take the shortcuts in creating the custom subnet mask. For this scenario, we need to create 60 subnets with 1,000 hosts per subnet. We've been assigned a Class B address of 128.16.0.0. The default subnet mask for a Class B is 255.255.0.0. In a Class B address, the first two octets are reserved for the network portion of the address, and the last two octets are reserved for the host portion of the address. If we write out the default subnet mask in binary, the first octet consists of 8 binary 1s, the second octet is 8 binary 1s, the third octet is 8 binary 0s, and the fourth octet is 8 binary 0s. So if we add up all the bits that are turned on in the subnet mask, we have 16 bits turned on. We can represent the subnet mask by writing /16. The first rule of subnetting is that we have to borrow at least 2 bits and that we have to leave at least 2 bits for the host portion of the address. We have a total of 16 bits available for the host portion of our address. 8 bits in the third octet and 8 bits in the fourth octet. This means that the maximum number of bits we can borrow, according to the first rule of subnetting, is 16 minus 2, or 14 bits. Let's find out how many bits we have to borrow. This process works just the same way as we outlined in the videos about subnetting a Class C address. We write down the decimal value of the bits and start adding them together from the right-hand side. Our goal in this step is to come up with a number greater than the number of subnets we're looking to create, or greater than 60 in this case. If we borrow 2 bits, we add the value of 1 plus 2 together to get 3. 3 is less than our goal of 60, so we know we need to borrow more bits. If we borrow 3 bits, we add the value of the first 3 columns, 1 plus 2 plus 4, to get 7. 7 is still less than 60, so we know we need to borrow even more bits. You should notice something interesting here. The sum of the number of bits is one number less than the value of the next column. The value of the fourth column is 8, and when we add the value of the first 3 columns together, we get 7. Knowing this shortcut will save us time. Rather than adding more values together, we can look at the values of the column and find one that's greater than our goal of 60. 64 is greater than 60. The shortcut we just learned tells us that 63, or one number less than 64, is what we would get if we added up the first 6 columns. If you want to double check this, find the sum of 32 plus 16 plus 8 plus 4 plus 2 plus 1. Great. Now we know we need to borrow 6 bits for our scenario. The second rule of subnetting tells us that if we raise 2 to the power of the number of bits we borrowed and then subtract 2, this gives us the number of usable subnets. We just determined that we need to borrow 6 bits for our scenario. Using the second rule of subnetting, we raise 2 to the power of 6 to get 64 total subnets. We have to subtract 2 to get 62 usable subnets. Regardless of the number of subnets created, we can never use the first subnet since it contains the network or wire address of the particular class of address, and we can never use the last subnet since it contains the broadcast address of the particular class of address. We have 62 usable subnets, and we only needed 60. So that gives us a little bit of room for growth. The third rule of subnetting tells us that 2 to the power of the number of bits remaining minus 2 gives us the number of usable hosts per subnet. Since we're working with a Class B address in this scenario, we started out with 16 bits available for the host portion of the address. We determined that we need to borrow 6 bits for the subnet portion of the address, so we have 16 minus 6, or 10 bits left over for the host portion of the address. Using the third rule of subnetting, we raise 2 to the power of 10 to come up with 1,024 total hosts per subnet. We have to subtract 2 host addresses from this number, since the first host address of each subnet is the wire or network address for the subnet, and the last host address is the broadcast address for the subnet. So 1,024 minus 2 equals 1,022 hosts per subnet. This gives us a little bit of room for growth in the host per subnet, since in this scenario we only needed 1,000. Before we apply the fourth rule of subnetting, let's revisit the custom subnet mask we created for this scenario. The default subnet mask for a Class B address looks like this. All 8 bits are on in the first octet, and all 8 bits are on in the second octet. The imaginary line separating the network portion of the address from the host portion of the address is right here between the second and third octets. We said that we need to borrow 6 bits. Do you think that we need to borrow them from the left-hand side or the right-hand side of the subnet mask? We borrowed them from the left-hand side since we effectively need to move the imaginary line over to the right by 6 bits. In previous videos, we said that if a bit is turned on in the subnet mask, or represented by a binary 1, it's part of the network or subnetwork portion of the address. Since the first 6 bits in the third octet are now turned on, the 6 bits in the third octet are now part of the subnet portion of the address. We have to move the imaginary line over to the right by 6 places. In the next video, we'll calculate the increment for the network address and complete the Class B subnetting scenario.